Hello everybody, and welcome to our lesson on the distributive property. The distributive property is kind of a cool thing. It allows us to break the rules of order of operations. Remember, if we were to see a problem like this, order of operations, or GEMS, reminds us that we should start with our grouping symbol first. 4 minus 7 would get evaluated to give us -3. Then we could work our way down to the multiplication. 3 times -3 gives us -9. And if that's all we have to do, that works pretty well. But what if we can't do what's in the parentheses first? What if instead of 4 minus 7, our work in the parentheses said to do something like x minus 7? Unless I know what x is, I'm not going to be able to figure out what the quantity x minus 7 equals. Does that mean that I'm stuck? Actually, no, I can keep going. That's where the distributive property comes in. First, a little visual. Let's see I wanted to multiply the quantity x plus 3 times 2. Again, unless I know what x is, I can't actually do the work inside the grouping symbols first. But if I were to draw this out, hey look, it's an x. And my 3 is going to be represented by 3 little individual squares that each represent a 1. X plus 3. When I multiply something times 2, that means I want to double it. So I'm going to repeat that exact same series of pictures to represent another x plus 3. Well, what do I have now? I have x plus 3, and I've doubled it. So all told in my picture, I have 2x plus 6. That's what we get when we distribute the 2 to the x plus 3. The trick to the distributive property is we have to multiply this term outside the grouping symbols by every term inside the grouping symbols in order to do our multiplication first. And that's called distributing. We can indicate it and help us remember to multiply by every term inside the parentheses by doing some happy little rainbow arrows. We have to multiply the x times 2. We have to multiply the 3 times 2. So algebraically, now we can see where we get 2x plus 6 from. Now that we've seen that example, let's go back to the original problem I posed and see if we can apply the distributive property there. If I want to multiply 3 times the quantity of x minus 7, again, I need to make sure that the 3 is multiplied by all of the terms inside my parentheses. So 3 has to be multiplied by x. I copy down the minus sign, and 3 has to be multiplied by 7. 3 times x gives us 3x, minus 3 times 7, which is 21. So now I've simplified that with the distributive property. What happens if there's more than one variable in the expression that I'm trying to distribute? Maybe I have something like k times the quantity k plus 1. Again, make sure to distribute k to all of the terms inside the parentheses. So this k will be multiplied by this k, and this k will be multiplied by 1. What happens when I multiply k times k? Well, any value multiplied by itself can be represented as that value squared. So k times k gives us k squared. Plus k times 1 gives us 1k, which hopefully we remember is the same thing as just letter k. All right, now it's time for you to try. On your paper, you need to do these 3 problems now. You don't see 3 yet, but please put a triangle around do now number 1. Here are the 3 problems I would like for you to do. Let's see how you did. 12 needs to be multiplied by x and by 4. 12 times x is 12x, and 12 times 4 is 48. For letter B, Notice I'm still drawing in all of my arrows and rewriting it just to make sure I don't leave anything out. X multiplied by itself is x squared. X multiplied by 5, well, a letter and a number multiplied together, we know that that coefficient has to come first. So we get 5x. Last but not least in this set of examples, 2n multiplied by n, and I copy down my minus, 2n times 9. Squeeze that in on the edge of my paper there. 2n times n, well, n times n is n squared. Since it's also multiplied by a 2, I get 2n squared. 2n times 9, 2 times 9 is 18, times n. So 2n squared minus 18n. How'd you do? Okay, stage 2 of our notes. Let's talk about 3 common errors that people make when they're distributing. 1, they might make a mistake in their exponents. 2, they might not distribute to every term in their parentheses. Or 3, they might make a mistake with their plus and minus signs. Let's first talk about category number 1, a mistake in exponents. To help understand that better, I want to remind you, x plus x is equal to 2x. We learned that last time when we were talking about combining like terms. But x times x is equal to x squared. That's an important difference to note, especially since we just finished a lesson where we were talking about you can only add or subtract terms if they are alike, meaning they have the same variables to the same powers. But with distributing, we're doing multiplication, and the truth is, you can multiply anything together. Even if the terms have variables that aren't the same, you can still multiply those 2 terms together. You'll just end up with a term that has multiple letters in it written side by side. So, for example, while a plus b is still just a plus b because it can't be simplified anymore, a times b becomes AB. I write those 2 letters side by side. You want to simplify this expression by eliminating the multiplication dot. This still shows that they're multiplied together. Whenever 2 things are side by side in algebra, that means they're multiplied together, but in a slightly shorter way. You can also start to multiply some terms that become a little bit bigger and more complicated. 5a times 8b. Well, 5 times 8 is 40. AB. Since these are different, all I can do is write them side by side to show they're multiplied. Or 6a times 3ab. That becomes 18. And then a times a gives us a squared times this b. So we have to make sure that we're keeping straight addition versus multiplication. Only like terms can be added or subtracted, but any terms can be multiplied. And if I'm multiplying 2 variables that are the same together, that's going to change the exponent. So take a look at this example. X multiplied by the quantity of 3x plus 4y. If I were to distribute in this case, x multiplied by 3x gives me 3x squared. X multiplied by 4y gives me 4xy. All I can do is make sure my coefficient is still at the front and write my variables side by side to show the multiplication. But over here, this is the place where some people make some errors, and they might accidentally try to add these together, or not change the exponent on the x because they confuse the multiplication with the combining like terms. Be careful about that. Let's take a look at another example just to make sure that we've got it. 2g to the 3rd power multiplied by the quantity of g squared plus 7g minus 8. Distribute this term to everything in the grouping symbols. So first to the g squared, then to the 7g, then to the 8. And again, notice I am just copying the addition and subtraction signs in the middle. 2g to the third power times g squared. Well, it might be confusing exactly what exponent we should end up with in this case. Think about writing this out in expanded form. G to the third power is g times g times g. And now we're multiplying that by g squared, which is g times g. When I take a look at it this way, it makes it a little bit more obvious that I should end up with 2g to the fifth power. Here, multiplying these two terms together. Coefficients always go to the front, so this 7 is going to come up here and multiply by this 2 to give us 14. Again, g to the third power written out in expanded form would look like this. Multiplied by this g gives us 14g to the fourth power. Last but not least, this one's a little bit easier since we don't have any g's back here. So I know that this term is going to have g to the third power, and 2 times 8 gives us the coefficient of 16. So minus 16g to the third power. Now sometimes when people work out examples like this, they make mistakes with their exponents, and they find terms that are alike in this stage of their work, so they combine like terms. If you did not have like terms in the grouping symbols to begin with, you should not end up with like terms once you have distributed. Now let's look at an example of mistake number 2, where people don't always remember to distribute to every term in the parentheses. For some reason, this tends to happen a lot more often when the polynomial in the parentheses is a longer one. Maybe they have a problem like this: 4 times the quantity of x squared minus 6x plus 11. People start to take shortcuts, which I understand, especially if you're doing a lot of work, and they'll write something like 4x squared minus 24x plus 11. What went wrong? Well, they multiplied 4 times x squared, and they multiplied 4 times this minus 6x, but they forgot to multiply times the 11 at the end. This is not correct. If you don't multiply by every term in the grouping symbols, you haven't correctly distributed, and you end up with the wrong answer. That's why I keep emphasizing both methods to make sure that you remember to multiply by every term, using our little rainbow arrows and writing it out as well. I'm not saying that you have to write both every time. Find which way works for you. 4 times x squared is 4x squared, 4 times 6x is 24x, and 4 times 11 is 44. Now we have correctly distributed that 4. Mistake number 3, I'm going to change colors here. Was making a mistake with your plus and minus signs. That's pretty common. So far, all of our distributive property work has been pretty easy because the term that we've been distributing has always been positive. So it's been very easy for us to copy our plus minus signs from within the grouping as we continue our work. And as long as this monomial out in front of the parentheses is positive, you can keep doing that. But we won't always be so lucky. Let's try something like this. It's pretty common for people to want to say something like that as their answer. The problem is that's not exactly correct. One of those signs is wrong. Can you figure out which one? Let's take a look. If I'm going to multiply using the same procedure I've done so far, I would need to multiply negative 3 times 4x, copy my subtraction sign, and then multiply negative 3 times 15. That is indeed equal to negative 12x, but I get minus a negative 45, which we know should be simplified to plus 45. There are a couple of things you can do to help yourself avoid these problems with plus and minus signs. One way you can avoid the issue is when you see that you have a negative term out in front of the group to be distributed to everything inside the parentheses. Change your subtraction signs to adding the opposite. That way you'll know every sign that you have to write down should be a plus sign, and all you'll have to do is pay attention to whether the products should be positive or negative. Negative 6d multiplied by negative 3d squared. A negative times a negative is a positive. 6 times 3 is 18. D times d squared, that's d to the third power. Again, I know it's going to be an addition sign. Negative times a negative is a positive. 6 times 10 is 60. D times d, d squared. Write my addition sign down. Negative 6 multiplied by positive 7 is a negative 42. Since this term has a d, although there are no other variables to multiply, I still have a d in my final term. That's one way to tackle this issue. The other way involves remembering something we talked about with combining like terms. When you're looking at an expression, a polynomial, like this is here in the parentheses, remember that you need to look in front of it to see whether it's positive or negative. Even if you would normally consider that sign to be an addition or subtraction sign, it can also be taken the other way and mean positive or negative terms. So, when I multiply this negative 6d times this negative 3d, I should know I get 18d to the third, and it's a positive because a negative times a negative is a positive. I know that this negative 6d times this negative 10d should give me a positive as well. So plus 60d squared. And then as I multiply my last pair, a negative times a positive gives me a negative, so I write down a minus 42d. Let's see how well you learn from the mistakes of others. On your paper, do now number 2, and draw a happy cloud around it. It should be a happy one because we're coming to the end of these notes. I've got 3 sample problems I want you to work out for yourself. Letter A, 3x squared times the quantity of x to the 4th power minus 9x. Letter B, the problem is 7b multiplied by the quantity negative 3b squared plus b minus 8. And letter C, negative 4n times the quantity n to the 3rd power minus 10n squared minus 5n plus 1. Pause now and start again once you're done. Now that you're back, let's see how well you did. I need to multiply 3x squared times x to the 4th and 3x squared times 9x. I'm copying down my minus sign. 3, no coefficient over here, I still have a coefficient of 3. X squared multiplied by x to the 4th is x to the 6th power. Minus 3 times 9 is 27. X squared times x, x to the 3rd power. There's our answer. For problem B, make sure that 7b gets multiplied by every term in the parentheses. Whoops, I started to write the wrong thing. It's another reason why it's good to write this out. Seven times negative 3 gives me negative 21. B times b squared is b to the 3rd. This becomes 7b squared. and this becomes 56b. Again, if you do this math and you see two terms that are alike, you need to go back and double check your exponents. Since we did not start off with like terms in the parentheses to begin with, we should not have like terms in our answer in the end. Final problem. Negative 4n times n to the third power gives me negative 4n to the fourth. I'm going to multiply this now by minus 10n squared. That gives me plus 40n to the third power. Multiply it times minus 5n. That gives me plus 20n squared. Multiply it times plus 1. Well, that's easy enough. That's just minus 4n.